Hello YouTube, got a quick video here with the Arduino Nano RP2040 Connect in the IoT bundle. Got this thing a little while ago and I just started playing around with it. Thought I would create this video for two reasons. When I was just getting started, I couldn't really find a good video on how to make a really basic circuit like this one, and two, I wanted to document my Arduino journey. I'm just going to start out with the components that I used for this circuit, and that would be the board, 2 wires, a 220 ohm resistor, and a blue LED. Now if we take a quick look at the pinout diagram for this board, we can see all the pins and their corresponding numbers. The Nano RP2040, which I'm just going to call 2040 for short, has two main types of pins, digital and analog. Basically, from what I can understand, the digital pins are like on and off switches. They can be set to high, which is like the on state, and in this state they output like 3.3 volts, or they can be configured to low, which is like the off state, in which they output 0 volts. Analog pins are different and can read a range of voltages from different sensors and potentiometers, etc. So for this build, digital pins will be just perfect. I chose digital pin 9. Don't ask me why, I just randomly chose it. And so that's the 4th pin on this side over here from the top. So you can either count these, or you can, if you line your board up correctly, you can just use the numbers on the side of the breadboard, which are over here. And then so I just have a wire running from digital pin 9 to this resistor, through the resistor LED, and then back to ground. And ground is demarcated nicely by these white marks on both sides here, which is super helpful. And that's just my super simple circuit. Again, I'm like just a beginner, and this is a super simple circuit trying to help out other beginners who are just starting out. Now, if you want to skip to the end of the video where I discuss the code, you can. However, I'm going to go over with a few more details about the resistor and the LED that I think that I learned that were super helpful for me, and kind of just giving you some more data about the whole circuit and how it works. First off, you may be wondering, how do you know which resistor is which? I got the whole strip of resistors, these guys over here, and I was like, how in the heck am I supposed to understand, which one is which and how much resistance they have, etc., etc. So I can link to a really helpful diagram that I found on the internet that shows kind of all the color codes for these different resistors. The one that I'm using, so if you want to identify it and use it in your own circuit, has 2 red stripes followed by 2 black stripes, then a final brown stripe, and this I believe signifies it as a 220 ohm resistor with a 1% tolerance. That kind of final line should demarcate the tolerance specifications, and that means it just varies by it can vary by that percentage of its resistance value, if that makes any sense. And I will say that with the colors, the brown stripe looks more red than brown to me, and the black stripes look more like dark blue, but you just kind of give it your best guess. This is a close-up of a resistor, and if you can see, we got those 2 red stripes, 2 black stripes, and then supposedly another brown stripe there. Alright, now you might be wondering how I came to the conclusion to use a 220 ohm resistor, as in, how did I know what resistance I needed? This can get a little complicated, however I linked to a video that explains this in depth and much better than I ever could. This is a basic overview. The 2040 board, which I have right here in this little diagram, so this diagram just kind of shows the wires coming out of the board, and then going through the resistor, and then this is like a symbol for an LED, and then coming back to like the ground on this side. Anyway, the voltage coming from the 2040 board out of the digital pin is 3.3 volts. And so there's this law called Kirchhoff's voltage law, or KVL, and this law basically says that the total voltage supplied to the circuit needs to be consumed by the sum of all the components within the circuit. So this 3.3 volts needs to be consumed by both the resistor and the LED. And this is important because if we just had an LED and only an LED in our circuit, then the LED would consume all of the voltage outputted from the board. And if the LED can't handle that voltage, the LED is going to burn out and it will no longer function. Luckily for you, I was an idiot and I hooked up this whole thing without a resistor, and it actually still worked. So it won't be the end of the world if you do it in this case, but I still think it's best practice to use a resistor just to get in the habit, and it also will probably extend the life of your LED. Anyway, so now we know that the total voltage supplied needs to be consumed by all the components in our circuit. Now we need to know how much our LED consumes. So I looked again this up on the internet, and I think I found the right LEDs, not sure. It does vary by color, which is interesting. So different LEDs consume different amounts of voltage. For this particular blue LED, it was between 3.2 and 3.6 volts, and this was called the forward voltage, which I'm pretty sure just means the voltage drop across the LED, in a sense, the amount of volts the LED consumes. It also said that the typical voltage was this 3.2 volts. So if we take the total 3.3 and we subtract out 3.2 from the LED, we get 0.1 volts for the resistor. Now we just go get a 0.1 volt resistor and we're good to go. Except it's not that easy, because resistors aren't measured in volts. They're measured in ohms. Luckily, we have another helpful law. This is Ohm's law, which says that voltage equals current, which is this I, which makes no sense, but it's I, times resistance. So, let me move this up a little bit. If we do a little algebra, we divide both sides by I, we isolate resistance. So I just rewrote it over here. So resistance equals voltage divided by current. We know the amount of voltage that we need the resistor to consume, which is a 0.1. And then, but what do we do about this current? And so this is where I went back to online and that manufacturer kind of reference sheet, and it said that to have the LED operating at the optimal brightness and kind of performing best, it should have 0.02 amps or 20 milliamps of current running through it. So we just divide this out. We get 5 ohms. Now we get a 5 ohm resistor. Well, it's also not that simple because it is kind of that simple, but the IoT bundle doesn't come with any 5 ohm resistors, which probably makes sense because it's a small resistor size, I would imagine. Anyway, I just tried to pick the lowest resistor value, which is the 220 ohm resistor. Why did I try and pick the lowest value? Well, if we understand a little bit about the basics of a resistor, we understand why we want the lowest resistor value. And that's because resistors restrict the flow of electrons and create a byproduct of heat. Now that heat isn't doing anything for us in this circuit, right? So like our LED is doing something for us. Those electrons are doing work, they're creating light. Now when they go through a resistor, they're not doing anything but creating heat, and that's not helping us out in this particular circuit. So it's kind of wasted energy in a sense. But it's not wasted if you're protecting your electronic or electrical components. So I chose the lowest value I could, and because it's a small circuit and I'm not running it very long, it doesn't matter too much. Okay, now one last thing to talk about is the LED. And so the LEDs in the IoT bundle look like this. They obviously have different colors. The sides do matter. So the long side is called the anode, and it is positive, and the short side is the cathode, and it is negative, and you do have to wire that up correctly. So this would be the positive side in this case, kind of connected to the resistor, which is connected to digital pin 9, and then the negative side is connected to ground. An easy way to do this, though, is if you're not sure which side is positive or negative, just flip it around until it turns on. That's kind of what I did. You don't have to be like super sciencey about it. Just flip it around until it turns on, but it won't turn on if it is oriented incorrectly. So this is just something to know. Again, positive side, that longer side, called the anode, shorter side, cathode, and that is the negative side. Okay, real quickly, just going to go over the code behind this little circuit and program here. And I'll also link to this in the video description as well. And I'll just try and make this quick because the video is already getting kind of long. Anyway, I just initialized a variable as LED pin right here and set it to digital pin 9. This is what this does. This is kind of just like establishing the connection between the board and the computer, I believe. I just copied this from like other examples. This sets the pin mode to output, so it's outputting a voltage rather than receiving an input. This is just a loop function, so this loops through this indefinitely. This turns the LED on. You can think of, and then there's this delay here, and you can think of this as the on time. This delay dictates how long the board is sending the command for the LED to be on. Then it tells the LED to turn off, and same thing with this delay command here. Super simple. Yeah, it's just about getting the syntax of the code right, I think, is like the most difficult part of it. So after taking a look at the code, the last thing we have to do is just kind of test this guy out. So I'll go ahead and plug this guy in. Oops. Just turning on there, and then should be running, doing this little blink about every 3 seconds, I believe. I haven't timed it or anything. And you can see with that 220 ohm resistor that we got that pretty nice glow. We got a pretty nice light, pretty nice and bright. Hopefully that helped someone out. And if you have any questions, you can put them in the comments down below. I'll try and answer them. Again, I'm a beginner, so I don't really know what I'm doing. And if you have any recommendations for me, I would love to hear it in the comments as well. Thanks for watching, and happy tinkering out there.